Okay, in this question we want to differentiate this equation. We will do it based on the exact equation method. And so we say p will equal the term for dx, so p would equal y, and our q term would be the one connected with dy. So q would be 2xy minus e raised to negative 2y. The next step we do is we differentiate p in terms of y. So the partial derivative of p in terms of y. So this would simply be 1. Then we do the partial derivative of q in terms of x, so qx, and this would be 2y, and this would be 0. And since they're not equal, we say it's not exact, but we need to make it exact. And so we can do that by using an integrating factor. And the two integrating factor that we're allowed to use will be e raised to the integral of py minus qx divided by q in terms of dx, and e raised to the integral qx minus py divided by p in terms of dy. And these are our only two options we can do if they're not exact. And the one that we choose will be the one that's more easier to do. And so if you notice, we're dividing by q and we're dividing by p. And q is pretty long, right? But p is pretty short, just y. And so the one that we're going to do is the easiest one, which will be this. Dividing by p is pretty straightforward. And so what we're going to get here is mu will equal e raised to the integral. So qx minus py divided by p. Qx is 2y, so 2y minus py, so minus 1, divided by p, which is 1. No, which is y. P is y. And this would be in terms of dy. And so what we're going to get here would be e raised to the integral 2y divided by y would be 2, minus 1 divided by y is minus 1 over y in terms of dy. And so this would equal, so we'll do e parentheses 2y minus ln y. This is the integral of this, and we're almost there. So we'll say that e raised to 2y times e raised to negative ln y. And so this would equal e raised to 2y divided by y. This is our integrating factor. And so now we will multiply our original equation by our new integrating factor. And so we said our integrating factor was e raised to 2y divided by y, and we're going to multiply everything here by it. And so we would get, so e raised to 2y divided by y times y dx would be e raised to 2y dx plus parentheses 2x e raised to 2y, 2x e raised to 2y, negative e raised to negative 2y times e raised to 2y would cancel and we would get 1. So minus 1 over y in terms of dy is equal to 0. Because this times 0 is 0. And so now we do the p and q again. So we say now p would equal e raised to 2y, and our q term would be 2x e raised to 2y minus 1 over y. We take the partial derivative of p in terms of y and the partial derivative of q in terms of x. So the partial derivative of p in terms of y would be 2e raised to 2y. The partial derivative of qx would be 2e raised to 2y. This would become 0. And since they are equal, so now exact. So we can do what we normally do for exact equations. So let me scroll down. And just to recap, our p term is e raised to 2y, and our q term is 2x e raised to 2y minus 1 over y. So now we take the, we do fx is equal to the integral of this in terms of dx. so e raised to 2y dx, and we do qy. So qy is equal to the integral of 2x e raised to 2y minus 1 over y in terms of dy. And so when we do that, this would be the integral of this in terms of x would be x times e raised to 2y, and the integral of this in terms of y would be x times e raised to 2y minus ln absolute value y. And we're the last step. So we say f parentheses x comma y is equal to, we take the unique terms from both of these equations. So we have here x times e raised to 2y, but we also have x times 2y also here. So we only counted once, and the other unique term we have is minus ln y. And so what we're going to write is x times e raised to 2y. We write it only once since it's repeated. We only want unique terms. Minus ln absolute value of y is equal to c. And we simply box in this answer, and that's all we need to do.